Okay, one of the key features we're going to be looking at are roots, intercepts, and multiplicity. So yesterday we talked about what happens at the end of a graph. Today we're going to talk about what happens in the middle. Okay, so what all the squiggly stuff that happens in the middle. Okay, so you have to know a couple of things. Roots and zeros of an equation. Remember, it's the x value when f of x is 0. And when I ask you for that answer or whatever, it's x equals value, whatever the number is, 2. If it hits the x-axis at 2, that's what you do. The x-intercept, you have to write as a point. And the y-intercept, where it hits the y-axis, you write as a point. So even though these two things are basically the same thing, if I ask you for an intercepts, write them as a point. Okay? Multiplicity is how many times a particular number is a 0. So it's basically the exponent. So x minus 3 is a factor. So we would do x minus 3 equals 0 and add 3. So the root is 3. Okay, so that's one root of the equation, but it has an exponent of 4, so it actually has a multiplicity of 4. So it actually happens 4 times it hits the x-axis at the same time in that spot. X equals 5 here. So we have x equals negative 5, x minus 5 equals 0, and so it has a 5 has a multiplicity of 1 because the exponent is 1 here. And if we set that equal to 0, we get 8. X is 8 with an exponent of 2, so it has a multiplicity of 2. So although this function only has 3 roots, 3, 5, and 8, it actually has a degree of 7 because of the multiplicities. So it has 7 zeros, or the degree of 7, because you're counting all those multiplicities. So cool things happen on the graph at those points where they have extra multiplicities. And the things that happen, well, when it's just a multiplicity of 1, it cuts through it just like a line would. Okay? When it has a multiplicity of 2, 4, 6, 8, whatever, it bounces off like a parabola. So if the root was 2, and it had a multiplicity of 2, it would bounce like that. If it had a multiplicity of 4, it would bounce like that, just as if it's an even multiplicity. If it has a multiplicity that's odd, everything except 1, 3, 5, 7, 9, it kind of jogs through it. I don't know what else to call it. Takes a break and then continues almost. It's going uphill, takes a break, and continues. So kind of has that evening off here, but it doesn't curve around. It jogs through it. So we're going to look at graphs and see if you can determine the degree of the graph just by looking at it. Okay, so first thing, you should be able to tell me what the roots are by looking at the graph. The roots are where it hits the x-axis. So roots for this particular one are x equals negative 1, x equals 1, and x equals 2. Everywhere that it hits the x-axis, that's a root. So if we know the roots, we can back up and give me the factors. So that's one factor. There's another factor. And that's your final factor. So the equation is going to look something like this. It's going to have an x plus 1, x minus 1, and x minus 2. But there's exponents on these guys. So if you look here, so let's start with this one right here. What is the multiplicity of each? So that's what we went to next. So we did the roots, that was these. The factors, where we backed it up and set it equal to 0. Okay, and now the multiplicity. So with multiplicity, we have to look, okay, this is not a cutting right through. It's more like a jog, as I like to call it. So the jog through at negative 1 here this is -1, it has to be an odd exponent, not 1. So we usually start with the lowest and just pick the 3. Okay? It could be 5, but we're doing a possible equation. We're not doing the exact necessarily. Though it is, because I made this, but whatever. The next one is +1. So right here is our +1. So this one hits and bounces off. So it hit and bounces off, it's like a parabola, so it would be squared. And this last one here, it just cuts right through, does nothing special, so it has a multiplicity of 1. So this guy, x plus 1 cubed, x minus 1 squared, x minus 2. And since they're asking for an equation, make sure you have some sort of equal sign. Equation means an equal sign. And we should look at the end behavior to determine to make sure that the leading coefficient isn't going to be negative, or if it is going to be positive. So if you look, these are going up and up. So this is, the degree is 3, 4, 5, 6. So it is even, and since they're both going up, that's the touchdown, that's the positive, so it will be positive. So it's should be both up, and it is. Okay. All right, so trying this one, if I give you an equation, can you sketch the graph? First, determine the degree. So if I look at this, how many answers am I going to have? How many roots are there? So here, there's 2 x's here because the exponent is 2, and there's 3 here. So the degree is 5. So this is an odd degree. What's the leading coefficient? Okay, the leading coefficient here is negative. Whatever's out in front, that's the leading coefficient. It's negative, so an odd negative leading coefficient, that means it's going to be going this way. Okay, it's going down the whole graph. All right, then find the y-intercept. So finding the y-intercept, that's when x is 0. So we simply plug 0 in for this guy. Okay, and when we plug 0 in, we get -2. So this is your intercept. Okay, so we know that it's going to go through that point right there. Mark the roots on the graph. So we know x minus 1 is going to be is a factor, and x plus 2 is a factor. So we simply solve it. So x equals 1, and x equals -2. So here and here, those are our roots. And then use multiplicity to graph the behavior at the roots. Okay, so at this root, at -2, the multiplicity is cubed, so we know it's kind of cut through. So it has to come from the top here, right? It has to come through the top, and it'll cut through. So I'm just going to do that. All right, I don't know how far down to go yet. I don't know my extremes, but I do know it's going to come back up. And at 1, it bounces off because it's squared. All right, so I know this is my behavior here and there. So last thing I need to do is find any extreme points. So when we're graphing, we do need to know our extremes. And if we do that in our calculator, you just simply do all the work. It's at -0.2, comma, -8.4. So 0.28 right around here somewhere. Label it, be like, yo, that's what that is. Oh, this is a terrible graph. But you get the idea. Okay, so we go down to there, cut up, bounce down. Wow. Anyway, this is why you use pencil, and mine does. Sometimes I can't erase, sometimes. So, use pencil, try to make it as nice as you can. Okay, sometimes we ask you to sketch, and sometimes we ask you to graph. These are the actual words that we use. Sketching is a little bit more liberal. We can leave off some stuff. So we don't need extreme points. When we sketch, we do need them when we graph. You definitely need to find intercepts and roots when you sketch, but labels are a little bit you know, you don't need them as much. So back up here, I probably should label. I did label my extreme point here. So this is a minimum. Okay, these are my intercepts, and just, you know, label your graph. F of x negative x minus 1 squared. Okay, just label everything that you got as you can. It's better to do. All right, have a good one.